In this video, I'm going to show you how to calibrate the CIT line depth for a few different plate types, and show you how to troubleshoot if the depth isn't quite right. First, I need to set up my system to be in plate mode, so I need to slide the gear shifter on the side of the loader to the front. And then, in the software's Preferences module, make sure the sample delivery mode is set to plate. Next, I'll go into the Acquisition module and create a default experiment for this demo. I'm going to add a 96 well U-bottom plate, a V-bottom plate, and a flat bottom plate. For each plate, I'm going to toggle to Plate View and assign a group from A1 to A3 by selecting the wells I want in the group, right-clicking, and selecting Add Group. I'll go back to List View and repeat this for the other two groups too. Next, I'm going to delete this group with a tube in it that came with the default experiment. Now I have my experiment with one of each plate type. I'm going to go ahead and grab my U-bottom plate and load it onto the cytometer into the loader. Once that's loaded, I'm going to go to the cytometer menu and click Calibrate CIT. For the U-bottom plates, we recommend starting with a value of 1.5. Then, click Calibrate CIT. While it is calibrating the CIT, make sure that the CIT line goes into the fluid in the well, but does not completely touch and bottom out on the bottom of the well. If you're happy with the CIT lift distance, go ahead and click OK to apply it. Now let's go ahead and try running well A1. I've added some DI water to the first well. I'll set my tube pointer there and click Start. Now what you want to pay attention to is your flow rate. If you notice that your flow rate is near zero, that's an indicator that your sample line is probably bottoming out in the plate well, and the flow is obstructed. You can see here I might be having that problem right now, as my flow rate is hovering between 0 and 1. I'm going to go ahead and click Stop. Wait for the CIT flush to complete. And then I'll return to that Calibrate CIT menu to redo the calibration. This time, I'm going to increase the CIT lift offset, maybe another 0.2 millimeters, for a total of 1.7 millimeters, and click Calibrate CIT. Once it's done calibrating, I'll click OK to set the value. Once the probe is done washing, I'm going to try previewing that well A1 one more time and see if my flow rate is back to normal or if it's still hovering around 0. I'll go ahead and click Start and wait for the boost to finish. For this run, you can see my flow rate is back to normal, around 30 microliters per minute when at medium flow rate. I'm pretty happy with that result, so now let's try a couple of other plates and see what the ideal CIT calibration is for them. I'm going to go ahead and click Stop and wait for the CIT flush to finish. Once that's done, I'll move my tube pointer to my next plate, and I'm going to unload my U-bottom plate and load my next plate. the V-bottom. Okay, let's go back to the Calibrate CIT section and calibrate CIT for the V-bottom. I'm going to increase it a little bit. So the V-bottom geometry, it's easy to get stuck on the side of that V-shaped conical bottom of the well. So you'll want a little larger offset than you would for the U-bottom. Once you've chosen a value to try, go ahead and click Calibrate CIT and click Continue. Then watch the sample line again and make sure it's not completely bottoming out at the bottom of the plate well. Once it's done, if you're happy with the value, click OK, and we'll wait for the CIT flush to finish. Now let's go back to the experiment. Again, we'll put the tube pointer to A1, and I have DI water in A1 again. Then let's click Start and see what happens to our flow rate. If you get this message, go ahead and click Continue. It never hurts to do an additional CalSIT before running the plate to make sure that nothing crashes during the plate run. Okay, once the flow begins, take a look at the flow rate. I see again that I'm hovering near 0, so it's likely my sample line is a little too low and hitting the bottom of the plate again. So let's go ahead and stop this, and we'll redo the CalSIT operation one more time and back it off from the bottom of the well a little bit more. Okay, we'll go back to CalSIT. In our cytometer menu, I'm going to increase the CIT lift offset a bit more. And again, all of this is in millimeters. Click Calibrate CIT and Continue, and wait for that calibration to complete. Click OK to store the value, and then let's go back to our experiment, again to well A1. And once the CIT flush is done, I'm going to click Start again and see what happens to my flow rate. Okay, this time my flow rate looks pretty good. So I'm going to go ahead and stop this plate run, and we'll move on to our last plate, the flat bottom 96 well plate. I'll go ahead and unload my V-bottom plate and place my flat bottom plate onto the system. Once it's loaded, I'm going to move my tube pointer to A1 and again go to the CalSIT menu. For flat bottom, the value I used for U-bottom should be a good starting point, so let's go ahead and start with that same value. Click Calibrate CIT and Continue. Again, watch the sample line and make sure it's not bottoming out at the bottom of the well during the routine. If it does bottom out, feel free to change the value. Otherwise, to keep it, click OK. Next, I'm going to go back to our experiment. I'll wait for the sit flush to occur again. Then once that's over, my start button is enabled, and I can click Start. Again, you'll get this prompt because we changed plate type in the experiment. So the software is going to do a CalSIT. Once it's done checking the sit and completing your fluidics boost, let's see how our flow rate looks for this plate. Okay, my fluid's coming through. I'm running at medium flow rate right now. And my flow rate looks pretty good. Right around 30 microliters per minute. So now I've found my 3 CalSIT values for each of my plate types. And if I remember these values, I can use them day after day for these specific plates. If I used other vendors' U, V, or flat bottom plates, I'll want to check the CalSIT for those and determine an optimal value for each vendor's plate type in order to run them on the Aurora's loader.